State and prove the modified Hamilton principle. The Hamiltonian solution. The Hamiltonian is H is equal to sigma I varying from 2n pi qi dot minus L is equation 1, where pi is equal to del L upon del qi dot, where I varies from 1 to n is equation 2. Here H is equal to bracket starts q1 q2 so on qn, p1 p2 so on pn and t, where qi dot q2 dot and so on qn dot are eliminated by using the equation 2. Now L is equal to sigma I varying from 1 to n pi qi dot minus H is equation 3. By Hamilton's principle, we have delta t1 to integral t1 to t0 to t1 L dt is 0. Let us consider the holonomic system with the independent generalized coordinates q1 q2 and so on qn, and we use the equation H p q t is equal to sigma I varying from 1 to n pi qi dot minus L to write the Hamilton's principle in the modified form. Delta integral t0 to t1 bracket starts sigma I varying from 1 to n pi qi dot minus H bracket close dt is equal to 0, equation 4. Applying the indicated variation in 4, we get sigma t0 to t1 integral t0 to t1 sigma I varying from 1 to n bracket starts pi delta qi dot plus qi dot delta pi minus del h upon del qi delta qi minus del h upon del pi delta pi bracket close dt is equal to 0, equation 5. As the time is held constant during the variation, that is delta t is equal to 0, integrating the terms pi delta qi dt by parts, we get integral t0 to t1 pi delta qi dot dt is equal to square bracket starts pi delta qi square bracket closed in limit t0 to t1 integral t0 to t1 pi delta qi pi dot delta qi dt is equation 6. Since delta qi is equal to 0 at t0 to t1, where 6 becomes integral t0 to t1 pi delta qi dt qi dot dt integral t0 to t1 pi delta qi dt is equal to minus integral t0 to t1 pi dot delta qi dt. This is equation 7. Putting the value of integral t0 to t1 pi delta qi dot dt from 7 into 5, we get sigma I varying from 1 to n square bracket starts integral t0 to t1 pi dot delta qi dt plus integral t0 to t1 bracket starts qi dot delta pi minus del h upon del qi delta qi minus del h upon del pi delta pi bracket close dt square bracket close is equal to 0, or integral t0 to t1 sigma I varying from 1 to n square bracket starts qi dot minus del h upon del pi bracket close delta pi minus pi dot plus del h upon del qi bracket close delta qi square bracket close dt is equal to 0. This is equation 8. Since we know that Hamilton's principle assumes varied path in q space, therefore the delta q dot s and p delta ps p's are directly related to the delta qs, and by equation pi is equal to del qi dot or qi dot is equal to del h upon del pi, where which implies that delta p's and delta q's cannot be chosen independently in equation 8. However, the coefficients of p are identically in 0 because of the canonical equation for delta qi, that is delta qi dot is equal to del h upon del pi, and so the value of integral remains stationary even if the delta p's are considered to be stationary. Now we consider the variations of the path in a phase space of 2n dimensions, namely the n q's and n p's. The modified Hamilton principle states that the actual path is such that the integral of the equation delta t1 to t integral t0 to t1 bracket start sigma even 1 to n pi delta q pi qi dot minus h dt is equal to 0 is a stationary for the arbitrary variations of the path in a phase space with the restrictions that the delta q's and delta q's vanishes at the fixed time to t1 t0 to t1. Delta p's may not be 0 at these end points. So delta q's are independent in equation 8, therefore it follows that the individual coefficients must be 0. As a consequence, we get that the canonical equation of delta pi dot is equal to minus del h upon del qi. Alternatively, if at the beginning of we assume that validity of the modified form of Hamiltonian's principle, then equation 8 will give 2n canonical equations.